Welcome to this Forge College Explainer. Okay, today you're stepping out of the EVM trenches and you're putting on the hard hat of the chief engineer. Your job? You're signing off on the final master blueprint for mapping the Ethereum virtual machine over to the Solana virtual machine. We are finally taking those rough, duct-taped concepts of yours and turning them into a sleek, factory-ready schematic.
But hey, before we send your schematic down to the manufacturing floor, we really have to embrace this very important engineering maxim. Measure twice, code once. And actually, let me add to that, especially when you are paying for Solana rent, right? Because unlike Ethereum, where you pay once and your data just kind of lives forever on a massive state tree, Solana literally makes you pay rent for the space you take up. Sloppy engineering here doesn't just look bad on paper, it drains your protocol's wallet, bite by painful bite.
All right, let's just quickly glance at our engineering table of contents. We've got the final blueprint, gathering materials, anatomy of a mapping, schema validation, peer review, and finally, ready for manufacturing. Let's get into it.
Starting off with Section 1, the final blueprint, moving from rough drafts to the master schematic.
So we're at the absolute culmination of your transition journey here. Think back to lessons 1 and 2. You were probably, pulling your hair out trying to force Ethereum's global state model into Solana's highly localized accounts. You were sketching out rough drafts, testing the boundaries. Then, Lesson 3 brought the harsh but completely necessary reality of peer review, where you actually had to defend those choices. And now we take those battle-tested drafts and formalize them into a beautiful, machine-readable final sheet. This isn't just an assignment, folks. This is your actual production blueprint. Moving right along to Section 2, gathering your materials. Let's assemble our structural components. Take a look at this list. You absolutely cannot just wing this from memory. You need your refined comparison table. That's your operational brain. You need the formatting template to act as your structural skeleton. The evaluation rubric is your strict quality control mechanism. And, crucially, you need that feedback log from your peers to prove you actually listen to them. So, grab all 4 of these components, synthesize them into one cohesive environment, and let's get to work.
Which brings us to Section 3, anatomy of a mapping. Let's look at the exact structure of a perfect engineering row. Really take a close look at this blueprint structure, because this is the beating heart of your deliverable. Literally, if you leave a column out, the whole machine breaks. Let's trace a core concept together. Say your EVM concept is a simple mapping of an address to a UINT 256 balance. Okay, in Ethereum, your storage example uses a Kashak hash of the owner and the slot, right? It's just part of a massive monolithic state tree. But on Solana, we localize it. Your Solana equivalent becomes a PDA, a program-derived address per key. The data layout is precisely defined as a packed U64 balance. Why? Well, that's your rationale. It localizes rent. Add in your operational assumptions, like the client deriving the PDA, and slap that reviewer sign-off email on the end. Bam! This single row is the absolute gold standard, providing every single detail a downstream engineer is going to need.
Let's just zoom in on that Solana equivalent column for a second. PDAs are your go-to minimalist solution for isolating state. For our EVM veterans out there, you know Ethereum processes transactions sequentially, literally one after the other. Solana, however, thrives on parallel processing. It's a whole different beast. By using per-key PDAs, you don't just localize the rent, you actively permit concurrent updates across different accounts. And that completely avoids the massive bottleneck of single large account growth that will absolutely paralyze a high-throughput protocol.
And similarly, if your EVM concept involves tokens, whether they're fungible or not, the ATA, or Associated Token Account, is your specialized container. It's this heavily standardized structure within the Solana ecosystem, which means you don't have to reinvent the wheel or, write risky custom logic when you're just trying to figure out who owns what token. Just use the standard, save your sanity, and keep your protocol interoperable.
Now thinking back to our table columns, think of the data layout as your exact factory parts list. You need explicit sizes, like a packed U64 or a 32-byte pub key. And please, whatever you do, don't forget your byte ordering. Be specific. And the rationale? Well, that's basically your desperate 2-sentence plea to the accounting department explaining exactly why this specific layout is efficient enough to justify the Solana rent cost. If you can't concisely explain why you structured the data this way, it's probably way too expensive.
Okay, Section 4, Automated Schema Validation. Time to run those safety diagnostics.
I mean, you wouldn't launch a rocket without running a diagnostic, right? Step 1, export your spreadsheet to CSV or JSON. Step 2, run the provided Python validator script against it. Step 3, fix the inevitable missing columns or blank fields it finds. But a massive warning here for the chief engineers in the room. If the Python script gives you a green light, that only means your schema conforms structurally. It just means you successfully filled out the boxes. It does not mean your logic isn't horribly flawed. A perfectly formatted bad idea is still a bad idea, so don't let a successful compilation lull you into a false sense of security.
And this brilliantly illustrates exactly what separates a rookie from a chief engineer in those diagnostics. Notice how a failing row just lazily writes the acronym PDA in the equivalent column. The validator rejects it, and rightfully so. Downstream front-end devs cannot deterministically derive an address from the vague concept of a PDA. The passing row, however, gives the exact seed array, the string literal balances combined with the owner's pub key. Vagueness gets rejected on the manufacturing floor. You absolutely have to be explicit.
Moving to Section 5, the peer review sign-off, quality assurance, and inspector approval. See that massive number 1 on the screen? That is your absolute minimum target. Yes, I know, developers typically hate doing code reviews, but you must hunt down at least one peer reviewer to explicitly complete the evaluation rubric for your work. We need their email or handle permanently etched into that reviewer sign-off column. Why? Well, so we know exactly who to blame if something breaks in production. Okay, I'm kidding, mostly. But seriously, this accountability step is non-negotiable. As the chief engineer, your quality assurance mandate requires 0 typos and total structural coherence. Before you submit, I want you to pick 3 representative edge cases from your sheet, maybe a single slot state variable, a PDA per key mapping, and a dynamic array, and cross-verify them manually. Trace the logic all the way through. Ambiguity in a spreadsheet today leads to a drained liquidity pool tomorrow. Get it right on paper first.
Finally, Section 6, ready for manufacturing. Let's export that final schematic package.
Your final submission isn't just one quick file drop. You need the final CSV export, the JSON export, your completed checklist, the peer feedback log, and a 15 to 600-word changelog. That changelog is incredibly vital, by the way. It's the engineering story of how your thinking evolved from lesson 2 until now, strictly based on peer feedback and technical realizations. Leave any one of these components out, and your package gets kicked right back to your desk.
So, the package is exported, the validations are passed. Which leads us to a pretty fascinating question. What exactly happens to this blueprint now that it's off your desk? It certainly doesn't just sit in a zip file gathering digital dust.
Next up, theory becomes executable reality. We're going to take this exact sheet and use it to translate Solidity access control patterns straight into Rust and Anchor code. All that meticulous work you just did defining pack structs and explicit PDA seeds, that becomes the immediate tangible foundation for building multi-signature guardians, ownership transfers, and complex role-based mappings on Solana. You've drawn the map. Next, we navigate it.
Thank you for joining this Forge College Explainer. I really hope you're incredibly proud of the master blueprint you've engineered today. Please visit forge.college to learn more about this subject and explore our comprehensive Web3 tracks. But I'm going to leave you with this final thought. If EVM state is just one giant, easily accessed monolithic tree, and Solana is a sprawling, parallelized city of highly localized PDAs, what entirely new application mechanics can you build now that you aren't forced to pay rent on the whole city at once? Think about it. See you next time.